So hello everyone, welcome to the Code for Everyone. And this particular video we are going to talk more about the linked list data structure, and we will try to see so how linked list data structure work, and we will do some of the crude operations. We will try to create linked list data structures. We are not going to use the APIs because when it comes about the competitive programming or tech interviews, so on those particular in those interviews we cannot use API to solve any kind of problem. Might be if you are using, then you need to take the confirmations from the interviewer, and if they ask you to create your own linked list data structure or any of the data structure, then definitely you need to start from the scratch. So let's understand the linked list, and I will take array as a reference for just comparing. Whenever I will try to compare with linked list, I will take the array as a reference. Okay, because pretty much we all are familiar about the array data structures. Okay, so as we know, so when somebody asks you to uh, declare one array, what generally we do, we create suppose integer, and we create array data structure, and then we do new int and size. So this is the syntax of creating array in any of the programming language. So what it does, it create array like this. Okay, suppose in the RAM, if this is the memory address 32,657, then it will be 58, and this will be 59 and 60 and 61. So this represent the continuous memory location. So if you see the nature of the array, it's a linear data structure. Similarly, linked list is also one of the linear data structure which represent a sequence of node, So here, suppose you have the RAM, and there are some, whenever you create one node, so suppose you have one node 1, another node you have 2, another node you have 3, and one node 4. So what generally we do, suppose this is the address 32,600, this address 32,601, 32,201, 600, 5, sorry, I'm taking 32,608, 32,201. So here it's linked list consists of the collection of the node together and represent in the sequence. So suppose, so this is the node 1 and node 2, node 3 and node 4. Okay, so what it does, so one node consists of the element, okay, or we can say, suppose here, suppose this is the node, okay, and this node will have the pointer or reference which point to the address, and first we'll have the data. This is how the syntax of the node looks like. So what we do, like node 1 will point to the node 2, node 2 will point to the node 3, okay, and here like this. This will have the memory location of this, and this will have memory location of this, and this is going to point null. So if you try to show it in the convenience way, so you can write like this. Okay, so this is how the linked list going to look like when we try to create in the memory locations, because this address will not be in the contiguous memory location. That is the reason, like, your array is more cache friendly than linked list. So to look at again, linked list is a data structure which is nothing but it's a collection of the node which together represent a sequence. And in the basic, it's in very basic form, if you can say that each node contains the data. So and data can be anything. It can be the primitive data type or a complex data type. You can class like customer class or user information or whatever you want. You can store the values in the data. And we will see why linked list is in what scenario linked list is more efficient than the array, and having array data structure, why we think about the linked list, and what kind of problem we try to solve using the linked list. So we'll try to look at those scenario as well. So another things you can say, right? So unlike array, linked list doesn't provide the constant time operations when you try to access any of the particular index. So what I'm trying to say is, for example, you have given one array 1, 2, 3, 4, 5, 6, suppose 10, 20, 30, 50, 40, 60, right? This is the array, and the index we have 0, 1, 2, 3, 4, 5, and you have given one linked list 1, 2, 3, 4, 5 and null, and you have the position 0, 1, 2, 3, 4. Okay, so if you are taking the position, do not take from the 0. If positions 1, 2, 3, 4 and 5, right? So what I'm trying to say here, that array gives the constant time operation when you try to read any value from the index. Suppose if I'm asking get number, right, and your function is you need to pass index. So simply what I can do, array of index, right, and it will return the values, and this is nothing but it's a constant operation. But this reading the index value and this process, right, we cannot achieve in the linked list. And if I'm asking, okay, get number, okay, and integer position, right, so I cannot do, okay, this dot, I cannot do like head of position, and I cannot do this representation of returning the value, and this is not going to work in the linked list. Okay, and it's not only about the middle element or the beginning or last element. Any index element you can access in the array with the constant operations. But here if I'm asking, okay, give me the kth element, so what you need to do, you need to create one current variable which is going to refer the head, and you need to write for loop, and you need to traverse from 0 to k minus 1 just to get the kth node, and this kth node will have the value and you can return this value. Another benefit of the challenge what we face here in the array, right? If I will ask you insert one item at the beginning or insert one item at the end, right? Suppose I'm asking to insert 70 and I'm asking you to insert at the beginning 9. With this two operation is not possible. But here if you know your head node, right, and you know the tail node, so adding and removing at the beginning and the end, it's a constant operation for inside the linked list. And another things we have seen that when comes of the memory representation inside the array declaration, it's going to be the contiguous memory locations where the linked list is not. So we can say that array is more cache friendly, but linked list is not cache friendly as array has. Another thing what we can see, right, so there are many data structures which has been implemented using the abstract signature of the linked list, right? Like list, we have the list, we have the stack, queue, and those data structure has been created using the linked list. So this is just simple introduction about the linked list. In the next video we are going to talk more about and we will try to do some of the trade like between array and linked list, and we will go like how indexing, insert, delete, and those operations time complexities, and in what are the scenarios and what are the circumstances your linked list is more efficient than other data structure. We will try to look those pieces as well, and we will see some of the disadvantages about the linked list. Okay, so thank you for watching this video, and if you're finding anything which need to discuss a little more, you can provide those information in the comment. Okay, so and I will look at those comments and I will try to I will try to clarify those questions in the next video. Thank you for watching.